In the last decade, headlines like this are all too common. As science educators, we have all asked ourselves, why is this the case? Is it the students? The teachers? We don't think so. We think it's the tools you've been given to use, and we're convinced that you cannot change your results by using newer versions of standard textbooks. At It's About Time, we do things differently. Our programs are developed with support from the National Science Foundation, and as a result, are research-based. Written by scientists and educators, not by in-house authors with little science or teaching experience. Extensively field-tested in schools throughout the country, large and small, urban, suburban, and rural, socioeconomically and racially diverse. We at It's About Time have an extraordinary inquiry-based program to show you, one that we believe can make a difference for you and your students. Project-Based Inquiry Science, or PBIS, is an inquiry-based program. So let's take a moment to define what we mean by inquiry-based. Think about it. Does hands-on equal inquiry? No. Not if students already know how the activity is supposed to turn out. Then it's simply validation, not inquiry. Inquiry is what scientists do. The best way for students to learn, enjoy, and appreciate science is by doing science as student scientists, through inquiry. Science teachers, administrators, and researchers agree that students ought to have the opportunity to learn through inquiry. This includes learning how to ask questions, how to design experiments, how to use evidence to support their claims. Students also must learn the facts, theories, and models of science and how scientists arrived at them. Inquiry cannot be just part of a science program that students experience one day a week for specific content areas, or only when they are in a lab. Inquiry needs to be the way in which they learn science, experience science, and understand science. That's sustained inquiry. Project-Based Inquiry Science was created to provide an atmosphere of deeper, more sustained learning than has been traditionally found in middle school science classrooms. PBIS units engage students in learning and respect students' need to learn within a context. In PBIS, the context is provided by the big question or big challenge found in each unit. Through the context of these questions or challenges, students develop a deep understanding of content. They also learn in the same way that scientists learn, through designing and running experiments, as well as by sharing their ideas with each other. Since students will mirror what scientists do, PBIS learning will help create not just good science students, but outstanding student scientists. They will be motivated, enthusiastic, and understand science in a way that will last a lifetime. PBIS is built on the research about how students best learn. What do we know? Learning occurs in context, learning is active, learning is social, and learning is reflective.
There is a screen that comes down.
Can I turn this around?
We got a water spider. It's a water beetle, I think.
Driven by projects to help students see ties between science and school and the real world, all of which are pertinent to students' everyday lives, and all of which involve important science concepts. Throughout the program, students are given the opportunity to do activities where concepts, skills, and content are introduced before there is discussion, direct instruction, or vocabulary introduction. We call this ABC design, that is to say, activity before concept. Students are given a wider variety of ways to be successful and demonstrate knowledge. In addition to traditional tests, quizzes, and homework assignments, students are expected to complete a challenge project, which ties together science, other school subjects, and their everyday lives. This allows for differentiated instruction and helps ESE and ESL students succeed. Districts using sustained inquiry-based materials report positive gains in many areas, improved scores on standardized tests, and most importantly, students in classrooms using sustained inquiry programs have a better view of their own science abilities.
It is so exciting to see students who are 10 and 11 years old just comfortably using technical vocabulary, connecting these concepts, making quantum leaps forward, pulling in conversations.
So it could be either, it could be an isopod or an aquatic sabo. How about...
It's just really fantastic. I'm very excited about this.
Covering his legs, his body.
Actually, 10 plus legs. sobug or an isopod.
What are the characteristics?
I really think that some students who may have been on the fence about what they thought they wanted to do with their lives are really thinking that, hey, science is fun. Science is something, you know, that, yeah, I'm thinking about doing.
Okay, wait, let's go through this.
What I want you to do now is move back into your regular groups, pull out your lab book, and we're going to update your project board.
One of the most important instructional components in PBIS is the ongoing use of the project board. The project board has 5 guiding questions. What do we think we know? What do we need to investigate? What are we learning? What is our evidence? And what does it mean for the challenge or question we're dealing with?
Each type of land use affects the water quality in different ways.
So you said each type of land use affects the water quality differently. What is your evidence for that?
Agriculture put like pesticides in the water and then fertilizer. And then
It helps students and teachers monitor their learning. For each challenge or question, students use the project board to keep track of what they know, what they are learning, and what they need to learn. Each PBIS unit is composed of a group of learning sets. Each learning set addresses a smaller, more focused question that needs to be answered to address the big question or big challenge. In each learning set, students perform a variety of different activities. They investigate, explore, discuss, share ideas, and read to help find answers to the learning set question. Then they share the results in a variety of ways to help make sense of what they are learning. These PBIS social practices are at the heart of the program's instructional strategies. By putting science in a participatory context, project-based learning helps to develop the social and interpersonal skills that will be needed to succeed in the workplace and as adults in the 21st century. In some learning sets, students will design and run experiments, design and build models, run their models, do procedures, and collect and analyze their data. While teacher guidance is provided to help students succeed at these endeavors, students are given the freedom and the responsibility to design solutions themselves.
Even the tiniest amount of friction that is enough, it'll stop right there.
Much like scientists, students are given the opportunity to modify and rerun experiments using knowledge gained from the initial experience. This iterative process is unique to PBIS and is tremendously valued in developing strong student scientists who understand and can apply scientific knowledge and concepts rather than simply recalling facts for a test or quiz.
Count how long it takes to get down. Ready?
Formative assessment opportunities are built into the program throughout a learning set. Updating the project board, stop and think, and reflect sections are important opportunities to evaluate student learning. Formative assessment and reflection are essential components of all PBIS activities. At the end of each learning set, the big question is revisited, and there is a small group and whole class discussion about what's been seen and done and what's been learned. Information is added and updated on the project board as the class moves towards developing an answer to the big question. At the conclusion of a unit, student groups plan a presentation of their solution to the big question, or they present their design for a challenge. This may result in students creating a poster, doing an oral presentation, or building a model, all of which will be shared with the class. There are several structured settings for presentations within a PBIS classroom situation.
On one path, it went down its own way. We didn't think it would go down.
This project-based learning is just one of the most powerful things that if we want to truly transform American education, this is the way we've got to go.
Now that you have a feel for our program's design, let's look at what we have to support teachers and students. We offer a strong teacher support package, including a full lineup of online teacher resources with enhanced teachers editions, projection masters, assessment generators, and a lesson planner. We also offer content and pedagogical support, which includes material lists, pacing guides, formative and summative assessment guides, strategies for differentiated instruction, and ELL. The Teacher's Edition also includes suggested teaching strategies and sample answers, as well as additional student reflection questions and even teacher reflection questions. In other words, PBIS is a complete program, with student editions both in print and online, teachers' editions in print and online, an exam view test generator, lesson view lesson planner, multimedia DVD, and teacher resource CD. We also offer our Learning Laboratory Classroom package. This includes all of the above, plus the hands-on equipment needed to complete all the activities, which serves 160 students. There are also many opportunities for students to use additional technologies like probeware associated with computerized data collection.
What is the project board? Project board is the display for everyone to see and use. You show to the class. It's also an individual product that the kids have.
Another essential component of our teacher support package is professional development. We offer everything from half-day introductory workshops to full-fledged 80-hour programs eligible for graduate credit and every conceivable option in between.
We're going to talk about 5 different characteristics of the project board.
Is it possible to change results? Absolutely. How? By selecting science materials that truly engage students, gives them a reason for doing science, programs that are project-based and has students working together in small groups, and programs that embrace the notion of sustained inquiry. One more thing. Be careful of standard programs with new labels. The word inquiry will jump out at you, but if content and vocabulary are presented before investigation, if there is no ongoing provision for students working collaboratively on a project or solving key questions, it's really not inquiry-based material. If the program doesn't start with some sense of students' prior knowledge and use additional knowledge gained by students and supported by evidence throughout the chapter, it's most likely not an inquiry program, just one labeled to get us to think so.
It's going in. Yeah! Yay!
Be careful of labels. All of us at It's About Time are convinced that together we can make a real difference for our students. Thanks for listening.